Hey.
Hey, Natalie. We have a very special guest today.
Yes, we do. We're so happy he's here.
So excited to have a true crime investigative journalist, nailed it, Billy Jensen, with us here today. Hi, Billy.
I'm so happy to be here and in a math class.
We heard you love math so much.
Yeah, I love math so much. And, I tell you one thing. I was an English guy. I was like a words guy.
Right.
But as I started getting more into crime, I really started dealing a lot with spreadsheets and dealing a lot with databases.
Yeah.
So I've had to use math a lot more than I thought I would.
Yeah.
I was just like, I'm just going to be a writer guy, man. All I got to do is I could just check up my word count and then that's it. That's the only thing I need to do. But yeah, math has definitely come into play, especially when we're dealing with how many unsolved murders there are in the United States, which is a lot. And that's
right. And that's kind of like your focus right now is a lot of, do you call it crowdsourcing or what do you?
Yeah, just citizen detectives. It doesn't always have to be crowdsourcing. It's how ordinary murders, and that's what I do is that I was an ordinary guy. Yes, I was a journalist for 20 years, but I figured out a way of how to solve murders using geo-targeted social media campaigns and using the crowd, and it's worked. So that's why what I've been doing right now is, through the Murder Squad podcast and through the book and all that, is just trying to teach people how you can do that and teach law enforcement how you can do that.
Right. And I love how you guys always say the rules so people know the way that's helpful and not hurtful. So We'll probably ask you to say those at the end here.
Okay.
Since our students are at home and they can all help, so.
Oh yeah. This is a great time to solve murders in your pajamas.
Right? Okay. I love it. Well then why don't we start doing some math?
Let's do some maths. Within the U.S. criminal justice system, criminal cases can be cleared or closed one of two ways. The first is through arrest, which means that at least one person has either been arrested, charged with an offense, or turned over to the court for prosecution. The second way a case can be closed is through what is called exceptional means, where law enforcement must have either identified the offender, gathered enough evidence to arrest, charge and prosecute someone, identify the offender's exact location, or come up against a circumstance outside the control of law enforcement that keeps them from arresting and prosecuting the offender. Now, the crime clearance rate for violent crimes in the U.S. in 2018 was 45.5%. That's really, really low.
Oh, really?
Yes. The crime.
I don't know.
If you have a violent crime committed against you, there's a 55% chance, or if we're in math now, so I'll say this.
I got it.
54.5% chance that the person will get away with it. Not even get arrested for it, because we're talking about clearance rate. So the crime clearance rate for violent crimes in the U.S. in 2018 was 45.5%. A citizen sleuth predicts that with equitable policy changes, crowdsourcing, and an increase in police resources, this rate is higher today. She randomly selects 1,000 public violent crime case files in the U.S. in 2020 and determines that 490 of them were cleared. What can she conclude at the 0.05 level of significance?
Okay, so let's identify some pieces that are going on here.
Yes.
That 45.5%. What do we want to call that?
We're gonna call that the null, right? The null hypothesis.
Well, yeah, we're going to go ahead and state that the null hypothesis is that the proportion of crimes that are cleared in this area is 0.455, right? So I'm going to call that P. I just kind of want to identify the variables real quick.
Oh, okay. Mm-hmm.
So then, so we'll get to the null and the alternative in just a moment. Let's just pick out all our pieces. What is our sample size?
The sample size is 1,000.
Yes. Okay, so we've got 1,000 cases that we're looking at, and how many of them were cleared?
490 were cleared.
Great, so I'm gonna let X be 490. So according to our sample, there is a higher clearance rate. But is that just sampling variation? Because you're not gonna get the exact same population value in every single sample. Or is that indicating to us that population value is no longer true? So we're going to go ahead and state our null hypothesis is what? Natalie?
So our null hypothesis, remember, is that nothing has changed so that it's left at that 45.5%.
Okay. So the citizen sleuth wants to see if that rate is higher today. So what does that tell us our alternative will be?
So the alternative is going to be that we are greater than 45.5%.
Beautiful. All right. So, and we see our sample evidence says that we are, but we need to see how compelling that evidence is. Is that like so stark that we need to reject that null hypothesis or not? So we will go ahead and assume true. The proportion is 45.5%. And then in our sample, we have a sample of size 1,000 cases. And we had 490 of them that were cleared. So our sample proportion was what, Natalie?
49%, right? Or 490 over 1,000, which would be 49%.
Yeah, which is definitely higher than what is said to be true for the population. So things are looking up a little. Still not good, Billy. Still not good. Still looking up. So
good, but I'll take it. Any help will do.
Yeah, any increase is good. So what we're going to do is see how dramatic that is using the p-value. So we can get the p-value either by hand or on the calculator. So we'll go ahead and show both. Okay, so to do this the by hand method, we do need to go ahead and draw a graph of all the possible different sample proportions we could have gotten if we had taken different samples. Our sample had a proportion of 49% of cases that were closed. But had we grabbed a different sample of 1,000 different cases, that rate could have been different, right?
Totally.
So we're going to go ahead and say, well, what are all the possible different p-hats that we could get? Now, one thing we do have to make sure is that our conditions are met before we just go drawing a bell-shaped curve. So I like to refer back where we have all the different distributions. And
love that page.
Yeah, this page is super helpful. You go back to it a lot, huh? All right, so the scenario we're in right now is that last one with the proportions. And one thing before we get into it is we have to remember the conditions that NP and NQ have to be bigger than 10. So the 10-10 rule, bigger than or equal. Since our N is 1,000, our NP is obviously going to be bigger than 10 because 45.5% of 1,000 is bigger than 10. And
yes,
likewise with the Q times N. Okay, so we can draw the bell-shaped curve, basically. Okay, and then what's the mean of
so that mean? Yeah, that mean was 45.5%, right?
Correct, 0.455. And then we need our standard deviation.
Yep. So, okay, we're going to find that using our formula.
Okay.
Which is the square root of that 0.455, right? The P.
P, yes.
Times Q, which is 0.545.
Cool.
All over N, which is 1,000.
Okay, and then do you want to give me like an approximation to that?
Yeah, so let's go ahead and say that's about 0.016.
Okay. And when we get to the calculator, obviously we will put the exact value in so we avoid round-off error.
Totally.
The value we want to mark off along the horizontal is the value we see in our sample for p-hat. Like we want to know where is our p-hat in relation to, you know, all the possible ones. And then we're remembering that this was a right tail test because of that greater than. So we're going to end up shading to the right of that. So we need to know where 0.49 would be on this horizontal axis. Yeah, so do you want to give me some values to the right of our center because that's the direction we want to go right now?
Yeah, so one standard deviation away would be 0.471.
Cool. Not enough yet.
Not enough. So then the next one would be 0.487.
Okay.
And then the next one would be 0.503.
Cool, we're far enough.
Yes.
Because 0.49 is going to be between those somewhere.
Mm-hmm.
And like we said, right-tailed test, shade to the right. So our p-value is going to be that area to the right. And if we know the boundary and we want the area, what's the function on our calculator that we use? Natalie?
The function, yeah, that function is the norm CDF function.
Cool. And then do you want to help me with the inputs on that, like lower bound, upper bound?
Yep. So that lower bound is 0.49.
Correct.
Which is why it's so nice to actually draw that bell-shaped curve, right?
Yes.
Otherwise, it's hard to visualize. Okay, and
Agreed.
then that area is going to continue to the right forever. So let's just put in a huge number there, which would be 10 to the 99. That's overkill, but that's just what we do.
Well, yeah, I like that you firstly commented on the graph because like a lot of people skip that part.
Yep.
And then also that this is overkill because the proportion really can never be bigger than 1. So if you put 1 there, you're good to go. Another quick note that you may have noticed, I'm getting a lot of emails about it, is a lot of students are writing 1E99 here because in the calculator, when the calculator gives you a capital E, it means 10 to a power.
Yeah, not the same.
Yeah, it's not a reciprocated relationship. When we type the alphabet button E, the calculator doesn't register that as scientific notation. So we have to actually write 10, the little caret 99.
Yes.
Worth noting. Okay, I got distracted. Tell me about the mean and the standard deviation.
So that mean was the 0.455.
Okay.
And then the standard deviation, let's just go ahead and copy and paste that gray up there, right?
Yeah, we don't want to approximate that.
No. Perfect.
Okay. And then we go to our calculator. Great.
Then we decided we were going to put 10 to the 99.
Okay, big numbers.
0.455.
Great.
Okay, and then the square root of 0.455 times 0.545, all divided by 1,000.
Thank you. Cool.
0.013.
Nice. We could also do this problem entirely on our calculator. And after doing a few by hand, I encourage students to do that. Where do you fall on that?
Yeah, the same. I mean, don't go straight to the calculator because we want to understand what all of this means.
Right. We just also, like, the thing we bring to the table is the interpretation. So we can let the
Absolutely.
Yeah. All right, so then you have to realize what kind of test are you in. That's kind of the hardest part if you're going to go the calculator route. So you have to ask yourself, what's the scenario? In this case, we have one sample we're looking at. It's a proportion.
Mm-hmm.
So which one are we going to use?
Probably that number 5, right?
Yeah, one prop Z test. So then we enter in the null hypothesized proportion for the population, the X value in our sample, our sample size, if it's a right-tailed test, left-tailed test, or two-tailed. So what was this?
This was a right-tailed test.
And then I like to draw it sometimes because then I can see, once if I'm not drawing it myself, I like to see the drawing. You don't have to, but then you see that little tiny area?
Ooh.
Yeah, and then
Cute.
your p-value. It's adorable. Look that's your graph, baby.
Yeah.
And then your p-value is right here.
Cool.
If you choose not to draw by hand or draw on the calculator, you can just get the p-value here, 0.013.
Yes.
And then if you are asked for the test statistic, you'll have that information. So your test statistic is right here for on the homework problems where it asks you for that. So what we end up getting is that the p-value is 0.013. Okay, and then our level of significance. Can you remind me, what was that?
The level of significance is 0.05.
Nice. So we'll put 0.05 here. And if we compare those two numbers, is our value less than 5% or greater?
Less.
Great. 1.3% is definitely going to be less than 5%.
Right. Mm-hmm.
And so if we have a p-value that's less than our threshold, our level of significance, what are we going to do, Natalie?
We're going to reject the null, right?
Yep, we're going to reject the null hypothesis. And that means
there is enough evidence to conclude that with those changes, the clearance rate has increased.
Nice. So that's a good sign, right?
Yes, that is a good sign. Let's make it into action now. Let's do it. Write it into law.
Right. Okay.
Don't do that.
Tell our students how they can help improve this clearance rate.
You know what? One of the biggest things that I would like to see is we have no national database that of murdered people or missing persons. They are all very scattered. We have 17,000 different law enforcement agencies. All of the information for older crimes is sitting in either police storage lockers or were lost in the flood, all this kind of thing. And I would like to see one national database where everything is flowed into. Now, as you know, the database is only as good as your data.
Right.
There are certain databases that are national, but not every state is forced to or required to enter the information in there. And it's super important. There's so many crimes that could be solved with, through that information. There's so many crimes that could be solved through DNA, through genetic genealogy, but we just don't have our act together because we don't have anything on a national level, and all of our data is scattered across 17,000 different databases. And it's unfortunate, but that's one of the things that I would hope students that are working on that have a interest in true crime would want to do something. And even if it's starting at a state level, collecting everything from a state level and then showing that you got to start somewhere. When I started with one case and I was able to show I'm a guy in my pajamas that solved a crime. Anybody else can do this too, just with a little bit of money and a little bit of tenacity. And you got to start somewhere. So that's sort of like what I'm hoping for data as it comes to crime and particularly violent crime.
Well, how do we get the data? Yeah, I mean, like old data, is it just a manpower thing?
It's not even it's a imagination thing almost. We put it out there in our first episode or second episode, one of those on Murder Squad. We said we called out every police department. We said, you know what? There are people that are out there that are willing to donate 10 or 20 hours a week to transcribe your old police files. They're all handwritten or whatever. I swear we have gotten maybe 1,200 people across the country saying, I want to do that. Yeah. We get about 10 each week. And that's an episode from more than a year ago. We get like 10 each week saying, I want to do that. We just need one law enforcement agent to say, yeah, let's try it. But I can't tell you how many old cases. And these are cases not even necessarily, I'm not talking about a case from a murder that happened 100 years ago. These are cases where the murderer still could be around.
Right.
I think a lot of people think that, if there's a serial killer in jail, say, for instance, in the state of Tennessee, if there's a serial killer in the state of Tennessee, which is where we were doing the first degree episodes that we're in the middle of, you think, his DNA must be in the system. But if you were arrested and put in jail before 1998, you're not in the system. So there's all other cases that could be in there, but they don't have your DNA. Your DNA is not going through CODIS, which is the national database, and it certainly isn't being tried against the genetic genealogy databases. And those are the things that are really super frustrating because there's a lot of cases that could be solved. There's about 240,000 unsolved murders since 1980.
Wow.
And that number just grows. It grows every year by 15,000. It's not like it's going down to in a huge way.
Right.
And we were able to, and when my partner Paul was able to solve the Golden State Killer case, it's 13 murders. And I was sitting there, feeling good because we get information that helped, was feeling good. But then I just look at the numbers, and that's when I drink.
Right. We feel you. We get you.
Yes.
Yeah, that's a lot. I just feel like with the data entry, I wonder if they're hesitant to just have people volunteer for it because of like data entry error or what? Like, what's the reservation?
Yeah, and that's what I said. I said, listen, there are, and I even use the examples of nurses who are used to reading bad handwriting, right. School teachers who are used to reading bad handwriting. Yeah, they're not, the data is not doing anything in a storage locker that nobody is seeing.
Yeah, agreed.
Bottom line.
Right.
And there are hundreds of thousands, I would say millions of people that are willing to work on it in the same way that there are millions of people that like to do fantasy sports, which literally means nothing. And they're willing to do that. There are a whole other set of people that are willing to do this, that could actually catch criminals that could be alive right now killing other people.
Right.
And, it's one of those things, especially when you're dealing with cold cases, the current administrations, they're just worried about last year's numbers. If last year's numbers went down, they look good. There's no real impetus for them other than I would like to think that if they're on the side of justice, they would want to do it. But there's no real impetus for them to want to actually go through and even it's not even that much resources too. It's just like, I said, like, give me one sort of citizen liaison officer in every big police department and have them just run that, And it's the excuse that you get a lot of times. I would see this in newspapers where, interns are too, to teach an intern and do this and that, it's too much, we'll just do it ourselves or whatever. And it's such a poor way of thinking. If there's people that are willing to do it and they're passionate about it, there's a way to get this done. And it's going to take, again, it's not going to happen on a national level. It's got to start from a lower level first, and then have it grow and grow and grow, and then have that person give a presentation and say, look what we did here with this, this, and this, and we cleared this, this, and this, and then have that continue to go.
Yeah, I wonder if like a little pilot program is just kind of what you need there.
That's what I'm looking for. A pilot program, not in too small of a place, but in, sort of a city that is, a mid-level city or a smaller city, not certainly like New York or Los Angeles, which are actually doing very, very well with their clearance rates, by the way.
Oh, that's good to hear.
Yeah, and there's certain cities that aren't doing well, like Chicago and St. Louis, but New York and LA have done well with their clearance rates. And here's the thing that happens. You do well with your clearance rates, you start arresting the right people, your murder rate goes down.
Right.
Yeah.
It makes sense, right? Yeah. So the fact that that's not a big sort of thing during the campaigns, during the mayoral campaigns or anything like that, it's just so low. It just makes so much sense to me, but it just hasn't really hit. And all it's going to take, like you said, is a couple pilot programs in some smaller markets, just to show that it works.
Yeah, I think that would be so cool. Well, if you ever need someone, I'm down to help too.
Okay.
So
Thank you so much.
If you need someone and they're good with records and numbers, I got you. I'll make my students do it for extra credit.
Oh yeah, that's the thing.
Yeah. But thank you so much. I know you're so busy and you're doing such important work, and you took time out to brighten up our students' lit video, and I know they're just gonna freaking love it. So
thank you so much. No, seriously, and thank you so much for listening and supporting us and stuff.
Well, I really would like to stay, but I have to go read my book.
Yes.
I'm very busy, so I'll let you get to it. Okay.
All right. Bye.
Bye.